Ever looked at a complex building and wondered how its electrical system actually comes to life? It's not magic, that's for sure. It's a really structured engineering process. And in this explainer, we're going to walk through that entire life cycle, right from the first idea all the way to a plan you can actually build from. So let's jump in.
All right, here's how we're going to break it down. We'll kick things off with a big picture overview of the whole life cycle. Then we're going to dive into each of the 5 key phases, one by one. Concept, preliminary, developed, detailed, and finally, construction. You'll see how each one builds on the last. So let's get...
All right, first up, Section 1, an overview of the electrical design life cycle. Before we get into the nitty-gritty, we need to see the whole roadmap, right? Understanding this framework is absolutely key.
You know, a great way to think about this process is like building with Legos. It's pretty obvious you can't just stick the roof on first, right? You have to build the foundation, then the walls. It's the exact same idea here. This is a sequential journey where every phase logically builds on the one before it. The choices we make way back in the concept phase, they have a direct ripple effect all the way down the line. It's this structure that makes sure the final design actually works. And this idea here really gets to the heart of it, progressive refinement. It's all about starting with a really abstract concept, just a bunch of ideas and requirements, and then methodically adding more and more detail at each step. Think of it like a funnel. We're pouring in all these broad ideas at the top, and with each stage, we refine them, organize them, and filter out the guesswork until what comes out the bottom is a crystal clear, buildable plan. Okay, on to Section 2, the concept design phase. This is square one. This is where it all begins. You know, taking that initial vision from the client and turning it into the very first high-level electrical requirements for the project. So, take a look at Figure 2 on your screen. This table pretty much lays out the blueprint for the concept phase. Let's break it down real quick. On the left, you've got the inputs. This is the stuff we start with, like the client's brief and some architectural sketches. Then, in the middle, the design column shows our main tasks at this point. And on the right, the deliverables, that's our output, which is a concept services brief. You can think of this document as the project's electrical DNA, really. Let's dig into the key parts here. The inputs are basically the what and how much. What does the client want, what's the budget, and what does the building look like in a sketch? The main design task, it's really just a quick back-of-the-envelope calculation to estimate the total electrical load, usually in watts per square meter. And our deliverable, as we said, is that concept brief. Now that last point is super important. At this stage, there's no real coordination with other engineering disciplines. And why is that? Well, everything is still way too up in the air. The whole goal here is just to paint the electrical scope in really broad strokes. All right, moving on to Section 3, the preliminary design phase. Now things start to get interesting. This is where that abstract concept we just talked about starts to look and feel like a real engineering scheme.
Now, as you can see here in Figure 3, the design is really starting to take shape. The key input now is that approved concept from the last stage. The design tasks get more specific. We're talking about initial sizing for major equipment, like transformers and generators. And check out the deliverables. For the very first time, we're seeing single-line diagrams. These are basically the first electrical roadmaps for the building. They show how power gets from the utility pole to the outlets, even if all the little details aren't filled in yet.
And this comparison really drives home how big of a jump this is. Remember, in the concept phase, all we had was a simple watts per square meter guess. But now, in the preliminary phase, we're actually placing and putting some initial sizes on the big ticket items. And that first single-line diagram, that is a huge milestone. It's the skeleton of the entire electrical system. We haven't added the muscle and nerves yet, you know, the specific breakers and cables, but the main structure is there. Okay, next up is Section 4, the developed design phase. Now, this is where the real heavy lifting begins. This is such a critical stage because it's where our high-level ideas finally meet some serious, rigorous engineering calculations. And for the first time, we start coordinating in a major way with the other teams, like mechanical and structural. If you look at Figure 4, you can see just how much the design is maturing. The biggest new input here is getting the actual service loads from the other disciplines. So now we know exactly how much power the HVAC systems need, how much the plumbing systems need. This lets us do some real detailed calculations. And as you can see in the deliverables, our single-line diagrams now have properly sized circuit breakers and main cables. The skeleton is finally getting some muscle. The workflow here is very methodical. First, we get a really precise picture of the power demand from those elemental load assessments. Next, we calculate what are called fault levels, which is basically a safety calculation to figure out the absolute maximum currents that could flow during a short circuit. That calculation then tells us what size our main distribution cables need to be. And all the while, we're talking constantly with the architects and structural engineers to make sure the physical pathways for all our cables and conduits will actually fit inside the building structure. And that brings us to Section 5, the detailed design phase. The best way to think about this phase is that we're creating the ultimate instruction manual and shopping list for the entire project. The number one goal here is to produce a complete set of documents so that different contractors can look at it and give an accurate price for the job. That process is called tendering. What you're seeing in Figure 5 is really the pinnacle of the design engineer's work on the project. The tasks get incredibly granular here. We're sizing the smallest final circuit cables and doing what are called protection discrimination checks. That's a fancy way of making sure that if there is a small fault, it only trips the closest circuit breaker and doesn't knock out power to the whole building. So the deliverables you see are now 100% complete. Every single component is specified. Every breaker is sized. It's the comprehensive blueprint. So this leads to a really important question. Can a contractor take these documents and just start building? And the answer, which the source material makes very clear, is actually no, not directly. These documents represent what we call design intent. They perfectly define the what equipment to use, what performance is required. And that's why they're perfect for getting a price. But they aren't construction drawings. They don't spell out the exact how of installing every little piece on a crowded, messy construction site. That's the final piece of the puzzle. And that leads us perfectly into our final section, Section 6, the construction design phase. This is the handover. This is where the design responsibility really shifts over to the installing contractor, whose job it is to translate our engineering design into something that's truly buildable. Figure 6 lays this process out really clearly. The contractor takes our detailed design package as their starting point, and their job is to create something called shop drawings. These are super detailed, large-scale plans that coordinate absolutely everything on site. These are the final, honest-to-goodness drawings that the electricians will use to do the actual installation work. And these shop drawings are absolutely critical. They're the missing link that translates the engineer's what and why into the contractor's how and where. They're used to resolve any clashes between, say, our conduits and some mechanical ductwork. They detail how things will be mounted and supported, and they confirm the exact dimensions of the equipment being installed. Basically, they make sure everything fits and can be put in place correctly and efficiently on a real-world job site. So where does that leave the design engineer during all this construction? Well, their role totally shifts from being the creator to being the reviewer. As you can see, their main job now is to review the contractor's shop drawings and equipment submittals. They essentially become the guardian of that original design intent, making sure that what actually gets built delivers on the performance, the safety, and the quality that was so carefully planned out through every single phase of this life cycle.